Leilani? You got it. Segment QR is congruent to segment TU. All right, one more thing based on the markings. Mm-hmm. Yep.
Would you say that the right angle QR?
Yep. Angle Q is congruent to angle T because we know right angles are congruent. Jonah, in number 2, tell me something that's congruent based on the markings. Perfect. Angle I has a loop with 2 slashes. Angle L has a loop with 2 slashes. So angle I is congruent to angle L. Sebastian, tell me something else that's congruent based on the markings. Good. Angle H has a loop with 1 slash and K has a loop with 1 slash. So we're going to say angle H is congruent to angle K. Jay, tell me something else that's congruent based on the markings. Say it one more time. Good. Yep. Segment KL is congruent to segment HI. Okay, so today we're going to learn how to prove triangles congruent. Or are we? Yeah. So today we're going to learn how to prove triangles congruent. But before we can learn how to prove triangles congruent, we're going to first talk about congruent figures, and the way we write things really matters. So congruent figures have the same shape and size. So first blank is shape, second blank is size. So remember, the word congruent means the same. If segments are congruent, they are the same length. If angles are congruent, they're the same measures. If polygons are congruent, they are exactly the same. They are the same shape. They are the same size. Their segments are the same. The angles are the same. Everything about them is the same if the figures are congruent. Okay, now this is going to be huge. When it's stated that two figures are congruent, the order of the letters absolutely matter. So do you see how it says triangle ABC is congruent to triangle FED? Since A is first and F is first, that means that angle A is congruent to angle F. So the way the letters are written absolutely matters because it tells you which sides correspond. This is a new vocabulary word. Correspond means the sides that match up together. That would be congruent if the figures are congruent. So since A is first and F is first, that means angle A is congruent to angle F. Because remember, if the figures are congruent, that means every part of them is also congruent. So angle A congruent to angle F. Since angle B is written, since B is written second, what does that mean? Angle B has to be congruent to which angle? E, because E is written second. So B is congruent to E. And last but not least, C and D are written last. So that means angle C is congruent to angle D. So we had angle B congruent to angle E and angle C congruent to angle D.
So don't think out like the dot.
Yep, and actually I'm going to try to trick you. So I'm going to draw the diagram where the letters are not sitting in the same spot. So let's say, see how I made it match up perfectly? Like B is bottom left, E is bottom left. So I would write ABC congruent to FED, but I would put E on this. So you would have to know that this bottom left is congruent to this bottom left. So you have to go by the way that the letters are written, not by how the diagrams are drawn. Okay, so now we know that since these triangles are congruent, every pair of corresponding angles are congruent. But now also every pair of corresponding sides are congruent, meaning they're the same length. Well, how would we know which sides correspond? Again, we're going to go back to the letters. So see how AB is written first and FE is written first? that means AB is going to correspond to FE, and they're going to be the ones that are congruent. So AB congruent to FE. And then we have, see how BC is then written and ED is then written? So that means BC will correspond to ED. So BC will be congruent to ED. And then the last pairing is your first and last letter. So AC and FD will be congruent.
Like if I switched like where like A, C, and D, F, like if I switch it, like do they have to be in order like that?
No, it doesn't have to. So now what we're going to do is based on these markings, we're being asked, would it be a correct statement if this is the way the letters were ordered? So they're saying, would it be correct if we said triangle ABC is congruent to triangle DEF? Well, we want to make sure that the corresponding parts are written in the same spot. So that means A and D would have to correspond. Do A and D correspond to each other? Are they the same, A and D? No, they're not the same because A has a loop with a slash and D just has a loop. So right away, I found something that was in the wrong order. So is this a correct way of stating these triangles? No. Okay, so now we're going to check the next one. They're saying, would it be a correct statement to say triangle EDF congruent to triangle BCA? Would this be correct? Well, let's see. They're saying E and B correspond. So look at the diagram. Do E and B correspond?
Yeah.
Yeah. Okay, then they're saying D and C correspond. Do D and C? Yeah, we're good. Then F and A correspond. Do F and A correspond? Yes. And as long as the angles correspond, the sides will also correspond. But if you wanted to check the sides, we can. How would we check the sides? So we'd look at the first two, ED and BC. ED, BC. We're good. Then we look at the last two letters, DF and CA. So DF and CA, they correspond. And then you pair your first letter with your last letter. So EF and BA. So EF and BA, they do correspond also. So you could have also checked the sides if you didn't want to check the angles. So this is absolutely a correct way to say those triangles are congruent. Okay, so Leilani, remember when I told you I was going to try to trick you guys? This is what I mean. And you should definitely expect something like this on your test. And you should definitely expect me to try to trick you on the test or the quiz when we get there. So the way things are drawn, you would think B and Y correspond. You would think C and Z correspond. You would think A and X correspond, but that's not the case. We don't go by how the things are drawn. We go by how the letters are written. So angle A is actually congruent to which angle? Jonah? Angle Z. Angle A is actually congruent to angle Z. So we want to mark it and then we write it. So angle A is congruent to angle Z. Okay, and then angle B, since it's now second, angle B is congruent to angle, which one? X, you got it. So angle B congruent to angle X. And then C is congruent to Y. Am I going to try to trick you? Yes, do not let me trick you. Okay, so now somebody tell me one pair of corresponding sides. Jack? Well, yes, we did the angles, but now let's look at the sides.
A to C Z1.
You got it. A to C and then Z to Y. So we're going to say AC is congruent to ZY. Jack M., you want to tell me another pair?
A root of
Excellent. AB is congruent to, oops, I put a wrong slash here. This was ZY. AB is congruent to ZX. And then last but not least is going to be BC is congruent to XY. Okay, so now let's see. Would this statement be correct? Triangle BCA and ZYX. So we double check. B and Z right away. Just checking the first one. Is it correct? B and Z? No. So we know right away this is wrong. We don't even have to check the other ones. Okay, so now we're going to get into the 3 ways of proving triangles congruent. The first way, there's going to be 3 ways to prove triangles congruent. The first way to prove triangles congruent is side, 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 meaning 3 sides of one triangle are congruent to 3 corresponding sides of another triangle. So let's write this down. Let's say it was given to us that XY is congruent to AB, XZ is congruent to AC, and YZ is congruent to BC. Okay, so let's mark it. So they were saying XY is congruent to AB, XZ is congruent to AC, and YZ is congruent to BC. So do you see how we're showing 3 sides of one triangle are congruent to 3 sides of another triangle? That means we would be able to conclude that these triangles are congruent. So I can conclude that triangle XYZ. Now, how would I match that up? If I said XYZ, how would you say the other triangle? You got it, ABC. That way we're matching up all the corresponding parts. And the reason would be SSS. So if we're able to show 3 sides of one triangle congruent to 3 sides of another triangle, we can say those 2 triangles are congruent by SSS. Okay, the next way to prove triangles to congruent is called side angle side. Now, here's the thing. It can't just be any two sides and any one angle. The angle has to be sandwiched between the two sides, or those two sides have to come together to make the angle. So what do I mean by that? Let's say I told you that XY is congruent to AB and XZ is congruent to AC. So given XY is congruent to AB and XZ is congruent to AC. Now we need, for side angle side, you need the two sides and you need the angle. You need the angle that's sandwiched between the two sides, or when you put the two sides with tick marks together, the angle that it makes. So what angle, Jay, is getting made between the two sides coming together? What two angles?
X.
You got it. So the angle, I can't just have any angle. I need the angle that's between the two sides that have marks. So we would need what Jay said, angle X congruent to angle A. And if we have all that, we can conclude that triangle. Now, if I say YZX, how are you going to match that up? Not Leilani, somebody else. So if I say YZX, how would you match that up for me with the right letters? Jonah? You got it, BCA. And the reason for this conclusion would be SAS. Okay, and now the last way we're going to learn today to prove triangles congruent is angle side angle. So it can't just be any two angles and a side. It needs to be the side that has the two angle marks on it. What do I mean by that? So if I say angle Y is congruent to angle B, and I say angle Z is congruent to angle C. So given angle Y is congruent to angle B, angle Z is congruent to angle C. Now the side, it can't just be any random side. It can't be like XY or BA. It can't be that for angle side angle. It has to be the side that has the two angle marks on it. So what two sides have the two angle marks?
YZ and BC.
Good. YZ, segment YZ, and segment BC. That has to be the segments that are congruent. So we're going to say YZ congruent to BC. And then we can conclude that triangle, I'm going to say CAB. So if I say triangle CAB, Kate, could you tell me how to match up the other triangle? So I said CAB. You got it, ZXY. And the reason would be ASA, angle side angle. Okay, so now what we're going to do is we're going to decide, would we be able to get to concluding that these triangles are congruent? It's either a yes or a no. If it is a yes, we're going to say the method that proves them congruent, and then we'd write down the corresponding triangle sides and angles. So here, based on our tick marks, we have three methods of proving triangles congruent. We have SSS, SAS, and ASA. Based on these tick marks, does it reflect any of those three? Stella? It is. AB and DE are congruent, angle B and angle E are congruent, and CB and FE are congruent, side, angle, side. And remember, for side, angle, side, the angle has to be sandwiched between the two sides that have tick marks. Are we good there? Absolutely. So here we're going to write SAS. Oops. And now we're going to match up the corresponding sides. So I wrote ABC. So to match that up, how are we going to write it? You got it, DEF. Jay, number 2, tell me, are these triangles congruent by any of these 3 methods? Yeah, which one? Perfect, ASA. And then Sebastian, I wrote HIG. Could you match up the other one for me? No, because J and H don't match up. So I said HIG. So who matches with H? You got it, KLJ. All right, you all try number 3 on your own right now, and then we'll go over it together. So you're saying, are these 2 triangles congruent? If it's a yes, then you say by which of these 3 methods. If it's a no, you just write none.
So was it for none? She said for right none. That, so we're saying like that.
All right, guys, turn it over. Let me see what you got. Good, very good. 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 The only thing is, guys, yeah, turn it over and then I'll tell you. Good. Good. I didn't trick anybody. Good job, guys. All right, this was a knot. And what do these tick marks say? This is ASS, right? ASS or SSA. If it says spells something we shouldn't be saying, then it's not a way to prove triangles congruent. ASS is not a way to prove triangles congruent. So here, when it's a none, what you're going to write is you're going to write none here, but then you're not going to fill out the triangles. You just put a line through it because these triangles are not congruent. So you don't still try to match up the letters because they don't match up because the triangles aren't congruent. All right, number 4. Do you guys see how we have a side, AD and DC, and then we have the right angle? Well, isn't BD the same side in both triangles? And isn't anything congruent to itself? So that's actually the reflexive property. Any segment is congruent to itself, and we're using it in a different way. Last time we were using it for addition or subtraction when we added the same side or subtracted the same side from two different things. But here we're physically saying this is the same exact side in both triangles, so it has to be the same length. It has to be congruent to itself. So now we can conclude that these triangles are congruent by SAS, side, angle, side. And then if I said BDA, then you would say BDC. All right, number 5, we just have two sides. We just have two sides. But does anybody see a pair of angles that we can say are congruent because we know that they're congruent? Not that we're assuming, we know that they are. Sebastian, this is like your favorite angles. Yeah. Do you all see the kissing birds? And we know vertical angles are congruent. So we can mark those congruent. Now that we have the vertical angles congruent, now can we say the triangles are congruent? Yeah. What would be the method that these triangles are congruent, Caitlin? For number 5? It's on the board. I can't hear you. I'm sorry. Look. Look on the smartboard. Look at the markings. So we just said the vertical angles are congruent, right? So if we look at one triangle, we have the two sides, right? And the angle that's made with those two sides coming together. What is that? Is that SSS, SAS, or ASA? SAS. So this is going to be SAS. And now you want to be really careful with how you match these up. So I wrote EC first. EC has one slash. So who does EC match with? That also has one slash in the other triangle. Isn't it AC? So you have to put AC first. So then it's going to be ACB. All right, Jack M, are these two triangles congruent? Yes. Do they look congruent, guys? No, but we never go by how a diagram looks because nothing's drawn to scale. The tick marks tell us they are congruent. So we're going to say side, 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 SSS. And now be very careful because the tick marks are in a different order. So the first segment is ED. So who matches with ED? BC. And then we got to be careful here to make sure it all matches up. So we have ED and then DF. Who matches with DF? AC. So we have ED, EDF, and then we're going to say BCA. Let's make sure. So does CA match with DF? Yep. Does BA match with EF? Yes. Okay. So we're good. So it's BCA. Okay. So you guys try number 7 and 8 on your own. And then just turn it over. Perfect. So you're good for the first one. For the second one. Isn't this the same segment in both triangles? So it has to be congruent to itself. So we mark that with an X. And then the triangles are congruent.
Yeah.
All right. So for the first one, what's up, Jay? Yeah. So for the first one, this is AAA, angle, angle, angle. Is angle, angle, angle a way to prove triangles congruent? No. So we write none. And we just put a line through this. And now for the second one, it looks like just AA. But because AD is the same segment in both of them, we could say it's congruent to itself. So now it's not just AA, isn't it ASA? And then I said triangle DBA, so you should say triangle DCA to match it up. Okay, so now this next part is we're saying what additional information would we need to say the triangles are congruent by the given method. So if I wanted to state that these triangles are congruent by side, 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 what extra information would we need to be told? Leilani? You got it. We would need AC congruent to DF. Now, same triangles, we're erasing AC and DF. Now we're saying those same base triangles, we want them to be congruent by side, angle, side. Noah, what additional information would we need for them to be congruent by side, angle, side? Yeah, which angles? Excellent. We would need angle B congruent to angle E. Okay, Sebastian, now we want these triangles congruent by side, angle, side. Number 10. What additional information would we need for it to be congruent by side, angle, side? So don't look at them at the same time, look at them separately. So for the first triangle, for it to be side, angle, side, what's the next side we would need? Okay, so remember for side, angle, side, the two sides have to come together to make the congruent angle. So isn't the congruent angle C? So one side that comes to it is AC, which we already have. What's the other side that comes together to make it? No, we're on the side. So what two sides come together to form angle C? AC is one segment. And what's the other side? What's the other side that comes to make that to meet at C? B2, C. Not just B, B's a point. BC is a segment. So AC and BC come together to make that angle. Do you see that? So we need that BC. Now in the other triangle, Sebastian, what's the other segment we need to make angle Y? So they have YZ. So YZ and which other side come to make that angle? You know, an angle is made up of two sides. So if this is angle A, right? No. Don't look at him, look at me. If this is angle A, right? It's two sides. Let's say this side come together. So BA, segment BA and segment AC come together and they form this angle. Yes? Okay. So when I say what two sides make the angle, in here, what two sides make this angle? What sides make the angle? How do you make an angle? Okay, I'm going to tell you again. Two sides have to come together. Two segments come together. It's actually two rays, but two segments can come together. So here's A and here's B. This is just one segment, right? To make an angle, I need to make another segment. If I put a segment down here, then I make angle B, right? But if I put a segment up here, what does that make? If I put a segment up here, what angle does that make? No, stop looking there. If I make an angle up here, what segment does that make? What angle does that make? Which angle? What letter? So I'm trying to show you how angles are made. So look, here's one segment. Is there any angle? Here's AB. Is there any angle made here? No. An angle needs two sides coming together, right? So if I want to make an angle B, where would I have to put the other side of the angle coming from which point? So if I want to make an angle B, I have to put a point from A. That wouldn't make angle B, that would make angle A, because look, the curve is by A. So if I want to make angle B, where would I have to make that segment? From where? From B. So what two sides make angle B? BC and AB come together to make angle B. If I want to make angle M, where do I have to put the other segment from? From M. And then I can make angle M, right? Okay, so now back to here. For it to be side, angle, side, you need an angle, right? We have the angle Y, and then you need the two sides that make that angle to have markings on them. So I already have what two sides make angle Y? YZ, and what's the other side that makes angle Y? YX. Is there a marking on YX? We need that marking for it to be side, angle, side. So now what's missing here? We need BC to be congruent to YX. Okay, so now if we need these to be congruent by angle, side, angle, Kate, can you tell me what additional information would we need for ASA? So for ASA, Kate, you need an angle, a side, and then another angle. But the two angle marks have to be on the segment that has the slash on it. So for the first triangle, we have angle C and we have segment AC, right? They have slashes on it. So what would be the last angle that we would need? No, we're looking at the first triangle right now. Triangle ABC. AC is a segment. For angle, side, angle, we need two angles and one side. Do you have one side with a slash on it? Do you have one angle with a slash, one angle with a loop through it? Yeah, so that means we need one more angle. So we have one angle, we have one side. But look, if I put, Kate, if I put the angle B, that's going to be wrong because that angle, side, angle, it has to be the side that's in between the two angles. This would be angle, angle, side. The side's not between the two angles. So what angle would make it where the side is in between the two angles? You got it. So I would need angle A in the first triangle congruent to what angle in the second triangle for it also to be ASA? So let's look. So if I do angle X, in the second triangle, is the sandwich between the two angles? No. So this is again where I'm trying to trick you. They're not sitting in the same spot. So which angle would make it sandwiched between? Z, you got it. So we would need angle A congruent to angle Z. Guys, are we understanding how I can play tricks on you here? We got to be really careful. All right. So now this diagram's complicated. I'm going to highlight the triangles we're trying to prove. So we want to prove triangle PTW. So I'm going to highlight that in pink. And we want that to be congruent to triangle SRV. Okay, Sebastian, if we want these triangles congruent by side, angle, side, what side do we need? So we already have, look at the pink one, we have a side and we have an angle. For it to be side, angle, side, we need another side. What side? No, we're in the pink triangle first. How do you name a side? With how many letters? 2 letters. A side is a segment. So we name a side with 2 letters. So here, what's the side that's already marked? Name it with 2 letters for me in the pink triangle. That has a slash on it, just the side that has a slash on it. Which in the pink triangle. PT, yeah. PT has a slash on it. And do you agree that angle T has a mark on it? Okay, so now for it to be side, angle, side, you sort of have to follow the pattern. So it's saying PT and then angle T. Now we need one more side. What would be the next side after angle T? Well, then you're skipping a side, right? So if you did PW, let's first look at PW. If you did PW, it'd be side, angle, skip TW, and then another side. We don't want to skip. So then if you look at the other way, it would be side, side, angle. Can't use that either. We want a side, and then an angle, and then a consecutive side. So say it one more time. What was the other one you said? Is TV a full side of the pink triangle? TW, just 2 letters. The first letter and the last letter, which is TW. You got it. So we need TW congruent to what side in the yellow triangle? Follow our same pattern. Use SRV. That's like making a whole triangle here. So look, you have SR is congruent, right? And then you have angle R. So now we want to follow the pattern. So we'll start here at S. So we have SR, angle R. Now what's the next consecutive side if we're following the order there? Oh, what would it be? SR, angle R, and then which side? RB, you got it. Perfect. No, you used 3 letters before. Oh, I didn't hear that. Why are you getting mad? Okay, so now if we want to prove these triangles congruent by angle, side, angle. Jay, could you tell me what's going to be the last piece we need here? For B, yeah. Perfect, but I can't call them angle P and angle S because there's more than one angle P and more than one angle S. So what we can do is we're going to name them with 3 letters. So we're going to say angle TPW. Oops, sorry. I wrote R, TPW. Congruent to angle RSV. So that would be these 2 angles. All right, we are done.